Good afternoon, everybody. I'm from Lancaster University in England. We're a fairly small university in the north of England, one of the top research universities in the country. We recently reorganised our academics so that they're not any longer in traditional departmental groupings, but they're in areas where we have particular expertise. So the technology I'm going to talk about comes from the Lancaster Environment Centre, which these days includes geographers, environmental chemists, ecologists, and also engineers working on renewable technologies. One of those is Georgia Giddis. You also notice that the other inventor of these technologies is from the UK Environment Agency. Recognising our preeminence in environmental technology, this government department has installed a small team within the department. The benefits of them are access to our academics, and for us, they bring real-world problems into the university. So I'm going to talk very briefly about some of the renewable energy work at Lancaster, and then talk about two designs of small hydro turbines. Our scientists work in two main areas. One is on wave power, the other is on low head water power. I'm not going to talk about wave power, other than to say it's a bit like battery technology. It promises a great deal, but progress is very slow. Now in the UK, we don't have the luxury of building any new barrages, flooding any new valleys. Our land's all used up, and we've got too many people. But we do have lots of fast-flowing rivers, and historically they were used for generating power. All the grain mills, cotton mills, woolen mills, but a lot of them have run into disrepair. And people these days are starting to look at whether they can be invigorated. Going the wrong way there. So the first one I'm going to talk about is in water networks. We have a lot of people in Britain, and not all the rain falls in the right place. I guess you have the same problem here in Phoenix. You probably have bigger and better pipes than we do. The small red dot on this picture is Lancaster in the north of England. The two red dots are Liverpool and Manchester. And if you can see the lines, they're bringing water from the Lake District in the north, where we have a lot of mountains. It rains a lot there. It rains pretty much all the time. Recently it snowed, and so the picture just shows you what perhaps looks more like British Columbia. It's actually England. So with all these pipes going across the country, water utility companies are now tightly regulated. In England, the water industry is privatised, but there's no real competition. The company you get depends where you live. And so the government has implemented a regulation system, and it's getting tighter and tighter on the companies. They're required to report more on the leakage from their pipes. And a lot of the pipes are old. They're from Victorian times when these big cities started running out of water. So these companies need to provide more and more telemetry from remote locations. Another factor in what we're doing is that the pressure in these supply pipes is rather large. If you were to just connect them up to your house, you'd have leaks. Water would start squirting out all over the place. So the water companies employ pressure reduction valves, which is what all these kind of machines are. And the way they reduce reduce the pressure, is by using up energy, basically by turbulence in the water. So as you go from high pressure to low pressure, it's wasting energy. So putting all these things together, our engineers came up with the idea of a pressure reduction turbine. So they've come up with a very simple design to fit inside a pipeline. And the idea is that you have the stator of your device built into the silhouette of the pipe, and you have a single piece rotor in the middle with a hollow centre that turns as the water goes through. So in more detail, the design is that the turbine will fit within the silhouette of the flanges where the sections of pipe are joined together. The single piece rotor has magnets around the circumference. As it turns, these interact with the stator coils in the housing, and so you generate power. Now, of course, this is not going to solve the world's energy problems, but it is going to produce tens of kilowatts, which can be used for remote telemetry, for powering water company buildings, and so on. And we've just come up with a new invention along the same lines, which is to turn a stop valve into a turbine. So the idea here is we have a rather more complex rotor. Instead of being a single piece, in this design you have two rings. As one rotates against the other, it turns the gear wheels, and each of the blades of the turbine is attached to a gear wheel. So as the two turn, the angle of the blades turns. And so you can change from a machine that's generating power to a machine that's giving you nearly 100% stop. Skip that, because we'll see a little later. The second invention is hydroelectric fish ladder. This has come about through our interaction with the UK Environment Agency, which has a number of roles, two of which come together and generate tension in this area. The first is that they're responsible for the protection and the maintenance of the natural environment, but they're also responsible for the achievement of renewable energy targets. The conflict arises when people want to put in small hydro schemes. So you'll see a headline in the newspaper that the Environment Agency red tape prevents the scheme. What's going on here is that a landowner may have a scheme which looks like it's economically viable. The Environment Agency says very good. Then the other part of the Environment Agency comes along and says, but we need environmental audit. You may require a fish ladder here because you've got to have continuous technology. When you do all the sums, it becomes non-economic. So the Environment Agency is actively looking for ways to get around this. Now, fish ladders can use a lot of concrete. There are lots of designs. On high-end systems, you need lots of compartments so the fish can go up and down slowly. So from these problems and existing, we came up with some requirements for what a fish ladder should do. So the new design that we have is a helix design, which allows a continuous water path. The fish can swim up and down both ways. It uses much less land than a traditional ladder. And what we then noticed was that as water runs down the ladder, it's rather like having a toy car on an inclined slope. By conservation of momentum, if the toy car runs down one way, the slope goes slowly backwards. And the same is true if water runs down the inclined plane. So if you free the axis and let this device turn, you get a torque. You can just connect that to a normal axial generator, and you can generate power from it. So not only do we have a nice design for a fish ladder, but we have a small turbine as well. So you can put this at the side of one of your dams and get two nice benefits. So where are we with these things? We've done a lot of computational fluid dynamics, which academics like to do, and we've done lots of lab testing, scale models, and lots of water sloshing around the labs. So far we haven't put any fish into them, so we're not quite sure what happened there, but our Environment Agency friends think it'll be good. So the state is that we're looking for partners now, engineering companies perhaps, utility companies, to try and build some full-scale working prototypes and see how these things work in practice. Thanks very much. Any questions on that? Question.
I'm Alison Weiss from the National Renewable Energy Laboratory, and we, obviously are in this space a bit. One of the challenges that we've had is to bring the business case to the laboratories in terms of being able to more readily commercialize the technologies that we're developing, prioritize our research so that it's fitting with what the marketplace needs. My question is, do you have a presence within your academic institution of the business community perspective beyond just the second party interpretation of the government agency stakeholders that you have?
Yes, we're working directly with some of the utility companies in the UK. We're very interested in this. They very much want to reduce their energy consumption. Getting the water from the source to the home, to the factory, uses far more energy than they'd like to admit at present. So anything that helps them, they're very keen on. I think perhaps the first installations will probably be on the basis of PR rather than economics when this goes in.
So that's the case with many sustainability initiatives.